Good evening, everyone. Again, this is Mr. McMahon here from Royal Oak High School, and today we're going to talk about two-step problems. So what is our goal? Well, first, our objective is to use our dimensional analysis to convert between representative particles, molar mass, and volume. Previously, we've been going from moles to representative particles, or moles to grams, or moles to volume, or vice versa. Now we're actually going to go in between these representative particles, molar mass, and volume, and skip the mole. So the only thing that does not change are the constants and the conversions. 1 mole is still equal to the molar mass. 1 mole is still equal to the representative particles, 6.022 times 10 to the 23rd, and it is still equal to 22.4 liters. Again, all of these are 1 mole, not 5, not 6, not 28, 1. So the concept itself is not going to change. You will still either multiply or divide as you did before, but we're going to have an extra step, and that's where some of you are going to have some issues that it's not the mole or it's not whatever you've done before. But again, just take it slowly, and I think you're going to be just fine. So this means whatever unit you start with, you will divide and have 1 mole on top. So the 1 mole is going to be the top piece. Then when you do the second one, the mole is going to be the bottom piece. Again, 1 mole, right here. 1 mole and 1 mole. So let's try one here. How many grams would be in 4.2 molecules of KCl? So think about that. I'm looking for what? Yep, you got it, grams. And what am I given? Right again, molecules. But the difference is there's no moles this time. So I'm going to have to first divide by what to cancel out my molecules? Man, you're on fire. That's right again. You're going to divide by the 6.02 times 10 to the 23rd. And if I want grams, what am I going to multiply? Yep, the molar mass. So let's see what that might look like. So what do I do? Well, we know that 1 mole of KCl has 6.02 times 10 to the 23rd formula units because it is an ionic compound. And that 1 mole is equal to the molar mass. Well, let's first figure out that molar mass. Again, I look in the periodic table and I see that 1 mole of K is equal to 39.10. Since I only have 1 in the problem, I multiply it by 1. And here I have chlorine is 35.45. I multiply it by 1. 35.45. And together I will get 74.55 grams per mole. So that's the first thing. I needed to know that because anytime you have mass, you need to find the molar mass. So step 1, again, doesn't look any different than before. First write out what you're looking for, then write what you were given. So how many grams would be in 4.2 molecules of KCl? So what do I want? Grams, and what do I have? Molecules. So x grams is equal to 4.2 molecules of KCl. Again, that's exactly how we're going to start. So we'll put that in there. We'll use what we already know for steps 2 and kind of 3-ish. And it looks like this. Notice, I've now added a second times line because I don't have moles here. If I don't have the word moles, it's always times line, times line. So I have to get rid of these molecules. That doesn't change. 6.02 times 10 to the 23rd formula units. That should be formula units. And on top, 1 mole. The reason I used molecules is because that's what your worksheet in class is going to be tomorrow. Or today, depending on when you're watching it. Or yesterday. And then look at this here. I have 1 mole on top, like I said first, and then 1 mole on bottom. And now what's going to go here? What do I want? The molar mass. That's right. So I looked that up, and from before it was 74.55. So I'm going to make sure that my molecules cancel. Now my moles are going to cancel, and I'm left with grams. And that's 5.22 times 10 to the negative 22nd grams. Now that's not a lot. That's actually very little. So not a lot of grams are needed here when you have this type problem. Well, what about volume? So let's try one here with the volume. So how many molecules of hydrogen gas would occupy 24.7 liters at STP? Again, write out what you're looking for, write out what you're given. I don't care about all these other numbers and molar mass and all that stuff. I just want you first to do what I've asked. What do you want? What do you have? So in this case, I want molecules, and I have liters. It's that simple. Do that first. That will set you on the path to an A. So again, using what we know for step 2, I know the molar conversions as well as the molar mass, but even though I don't need the molar mass, I won't use it here, but I know how to get it. So first, liters. And we said always what on top? 1 mole. And if I have a mole here, what do I need down here? 1 mole. So then what goes here? If I already have moles and liters, that's right, this thing I'm looking for. 6.02 times 10 to the 23rd molecules. Get rid of the liters, gone. Moles, gone. I'm left with 6.64 times 10 to the 23rd molecules. So I multiply 24.7 times 1, divided by 22.4, multiply it by 6.02 times 10 to the 23rd, divide by 1, hit the equals, and I get 6.64. So in conclusion, if you are given represented particles, then you divide by 6.022. If you're given liters, divide by 22.4. And if you are given grams, then you divide by the molar mass. Also remember that 1 mole is always on top for step 1 and bottom for step 2. The top portion of step 3 is always the constant for what you want. So it kind of goes mole top, mole bottom, what you want there at the very top. So your turn. Oh, nothing today. You'll have a chance in class tomorrow to work on these. Again, it was great talking to you all. Have a great day in class.